Alrighty, in this video we are going to be talking about justification in terms of increasing and decreasing intervals on the AP exam. Now, whenever we're justifying our answers, we always want to make sure that it's always related back to whatever they give you. So in this case, for number 9, they give us a graph of f prime. Because they give us a graph of f prime, our justification will always be in terms of, you guessed it, f prime. So for part A, we want to see where f is increasing. Well, f is increasing whenever f prime is positive. So I'm going to say that f of x is increasing whenever f prime of x is positive. This occurs from -6 to -2 and 2 to 5. B says find any x values in which f of x has a relative minimum. So remember, a relative minimum means that our graph of the derivative changes from negative to positive. So I'm going to say f of x has a relative minimum when f prime of x changes from negative to positive at that point. In this case, we could see that we change from negative to positive at x is equal to 2. So we know that x is equal to 2 is going to be our relative minimum. Part C says on what interval is f concave down? So looking at this, remember that we're given the graph of f prime. So if that happens, then f has to be decreasing. F is concave down when f prime of x is decreasing. So this occurs from -6 to -2, -2 to 0, and then 3 to 5. Notice how I did not say -6 to 0. Even though it is technically decreasing here, we do want to make sure that it is in terms of the domain of our second derivative. In this case, our second derivative right here is going to be undefined, so we don't know what's really happening at -2. All right, number 10. We're given the graph of f prime, and we want to find the x-coordinates of all points of inflections for the graph of f for 0 to 7. So remember, if I want to find the points of inflection, and given that we have f prime, this is whenever we are changing concavity, aka f prime goes from increasing to decreasing and vice versa. So here, you'll notice that at 2, f prime changes from decreasing to increasing, and at 6, f prime changes from increasing to decreasing. So at x is equal to 2, f prime of x changes from decreasing to increasing. And then at x is equal to 6, f prime of x changes from increasing to decreasing. Obviously, on the AP exam, I would encourage you to write out the full word decreasing and the full word for increasing, just so that the AP graders know that you actually mean decreasing and increasing. But I did that just at the same time. But don't do that on a test, and don't do that on the AP exam. Actually write it out. Part B says let g of x be defined by g of x minus is equal to f of x minus x. On what interval is g of x decreasing? So g of x is decreasing whenever our derivative is negative. So I have g prime of x is equal to f prime of x minus 1. So f prime of x minus 1 is less than 0, or f prime of x is less than 1. So looking at that, you'll notice that f prime of x is less than 1 here. So from 0 to 5. So I could say that g of x is decreasing from 0 to 5 because g prime of x is equal to f prime of x minus 1 is negative in that interval. All right, so now let's go ahead and look at number 11. We have the graph of g, and g is the derivative of f. And for a, we say from -5 to 6, on what open intervals, if any, is the graph of f both increasing and concave up? So we know that g is the derivative of f, so we know that f is increasing. When g is positive. In this case, we know that occurs between, let's say, 0 to 4, and then 4 to 6. And then we also know that if we're concaving up, f concaves up when g is increasing. So g is increasing occurs from -2 to -1, 0 to 1, and then 4 to 6. Now, if we combine that together, this tells me that I am increasing and concaving up from 0 to 1 and from 4 to 6. So we're increasing, concaving up from 0 to 1 and 4 to 6. Increasing and concave up from 0 to 1, 4 to 6. Part B says, find the x-coordinates of each point of inflection of the graph of f, and then we want to give our reason. So remember that we want to see where our graph of g is going from decreasing to increasing, or vice versa. So f has an inflection point. Let's see, where are we going from decreasing to increasing, or vice versa? So notice how here at x is equal to 4, because f prime of x is equal to g of x, changes from decreasing to increasing at that point. See how here we're still increasing technically, increasing. And then here we go from decreasing, but then we change from decreasing to increasing. So at 4. We don't want going still and then decreasing. That's not going to be our inflection point. All right. In the next video, we'll look at 3 different graphs. Well, the same graph, but let's say that to give you that graph being f of x, that graph being f prime of x, and then that graph being f double prime of x. And then we're going to see what happens with these problems here.